Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about LinkedHashSet in Java. By the end of this video, you will understand what LinkedHashSet is, what are features and internal working methods, advantages and disadvantages, and also when to use it. So let's get started. So what is LinkedHashSet? So LinkedHashSet is an implementation class which implements set interface. Okay, so we have seen the hierarchy. So on the top it is iterable. Okay, iterable, and then collection, and then collection has three child interface: list, set, and queue. Okay, so these all are child interfaces of collection interface, and iterable is also interface. So all of these are interfaces. Now set interface has implementation classes. So one is HashSet, another one is linked HashSet. Okay, linked HashSet, and the last one is the tree set. So these are what implementation classes. Why we are saying implementation classes? Because these are the classes which implements set interface. Okay, that's why we are calling implementation class. So there are different features of linked HashSet. Okay, what are those? It stores unique elements. Okay, the main difference is that linked HashSet maintains the order in which elements are inserted. Okay, and it allows only one null element. Okay, let's look at one by one. So linked HashSet implements the set interface. Okay, linked HashSet is the implementation class which implements the set interface. Okay, and it stores only unique elements. Okay, I hope you remember the two pointers I told. One is ordering and another one is sorting. Okay, so for linked HashSet, ordering is there but no sorting. What do we mean by ordering? Ordering means linked HashSet maintains the order of insertion. So the order in which elements are inserted in the linked HashSet. So when we retrieve the elements from linked HashSet, we will get in the same order. That means it maintains the insertion order. It remembers the position of an element. Okay, so that's what it is, maintains the insertion order. And since it implements set interface, and set interface has the property of having only unique elements, or in other words, no duplicates are allowed. So the implementation class will also have that feature. It will store only unique elements, no duplicates, and only one null elements is allowed in linked HashSet. Okay, and it is a part of Java collection framework. Why we are saying it is part of Java collection framework? Because map is different from map, does not belong to this framework and this collections interface. It has its own hierarchy. So for set, we are saying it is a part of Java collections framework. So these are the points we need to remember for linked HashSet. So we know this hierarchy. Linked HashSet extends set, okay, and indirectly implements the set interface. Okay, you can think like HashSet is the implementation class of the set interface. Okay, and linked HashSet extends the HashSet. Okay, and set is what? Set is the interface. Okay, so linked HashSet provides all functionality of the set. Okay, So linked hash set, it maintains order of insertion, okay, and no sorting. So these 2 points we need to remember for linked hash set. And this is hierarchy, since parent interface, then collection is the child interface of iterable, and we know that collection provides the common methods: add all, remove all, size, iterate. So these are the common methods which we can use in all three, like we have here list, set, and queue. Okay, these are the other two interfaces. So these are what child interfaces. Okay, so these child interfaces will have access to these common methods present in the collection interface. Okay, and whatever properties set is having, like unique elements, okay, no ordering guaranteed, so these properties will directly come to linked set. Okay, so set is an interface, ordering is depend on the implementation class. So but linked set provides the order of insertion. That means ordering is there but no sorting for linked set. Okay, so let's look at the features of linked set. So linked set combines the benefit of HashSet and linked list. Okay, why I am saying it combines the benefit of HashSet and linked list. HashSet and linked list. I am saying it combines the benefits of these two. Which linked list? Linked HashSet. Okay, so HashSet, what data structure it internally uses? Hash table. Okay, remember this point, this is important point. So hash table is the internal data structure for HashSet. Okay, and linked list is one of the data structure. It can be singly or doubly. So let's say doubly linked list. Okay, so if you combine these two data structures, you will get the linked list. So linked list, what is the data structure? If you say data structure of linked list is hash table plus doubly linked list. Okay, and apart from these, linked hash set removes duplicate elements. Okay, remove duplicate elements. Why? Because it is implementation class of the set interface, and it maintains the order, insertion order. Okay, so unique elements are allowed in the linked hash set. It maintains the insertion order. Only one null value is allowed. Okay, not synchronized. Not synchronized means faster in performance. Okay, we'll see this synchronized, unsynchronized in detail in the topic of multi-threading. Okay, but for now you remember not synchronized means faster in performance, faster lookup, and okay, faster lookup than many ordered collections. Okay, so these are the features of linked hash set, and the important one is the internal data structure, how it uses. So for hash set, internal data structure is hash table. Okay, and for linked hash set, internal data structure is hash table plus doubly linked list. It combines the power of both and uses it. Okay, why hash table? Hash table for faster in performance and doubly linked list for order. Okay, let's look at the internal working of the linked hash set. Okay, so internally linked hash set uses a hash table for faster searching. Okay, so here you can see internal working, you can see two things. Okay, one is hash table, another is doubly linked list. Okay, So here we are combining both hash table plus doubly linked list. What we are learning? We are learning the linked hash set. So linked hash set internal working, it uses data structure hash table plus doubly linked list. So why we are using these two? Because these two provides different features. What are those features? So if we are using hash table, we will get the feature faster searching. Okay, why faster searching? Because it uses hashing algorithm. So it will have the inside buckets. So it will use hashing. So we'll get fast search. That's why we are using hash table plus doubly linked list. Why doubly linked list? Because it maintains the insertion order. Okay, in the DSA, in the topic of data structure and algorithm, we will see in detail how it works. Head will be there, tail will be there. Okay, these are the nodes. Okay, how to traverse elements, how to traverse the nodes, how to manipulate, how to insert, how to delete, and how to search. So those operations we will see as part of data structure and algorithm. Okay, now we are learning linked hash set. So we are knowing that the internal data structure used by linked hash set is hash table and doubly linked list. Okay, so combining both combined structure, so like this, it uses linked hash set. Okay, so hash table for faster searching and doubly linked list to remember the insertion order. This is why elements are displayed in the same order they were added. Okay, that means it remember the order of insertion. Okay, so let's say if you are inserting element 10, 20 and 30 and you are retrieving the data, then it will come in the same order 10, 20 and 30. So this is the internal working. This is the very popular question in asked in interviews. What is the internal data structure for linked hash set? So what is the answer? The internal data structure for the linked hash set is hash table and doubly linked list. Okay, why? Hash table provides faster searching because it uses hashing algorithm, and doubly linked list, it maintains the insertion order. That means the order in which elements are getting inserted. So these two features are used by the linked hash set. Okay, so let's look at some example so we'll have better clarity. Okay, so what we are learning, linked hash set. Okay, so let us create one object of linked hash set. Okay, linked hash set, and I am providing string generic style. So we will play with the generics. Okay, so this object will hold only string type of object. Okay, so we created one object. Now we will add some element cities dot add. Okay, let's say Delhi, and cities dot add Mumbai, cities dot add Pune. Okay, so I added three elements, Delhi, Mumbai and Pune. Okay, now I will add one more element, but it will be same element, duplicate Delhi. Okay, so now what will happen? If I print cities, what will be the output? Since we know the property of linked hash set, that it does not allow duplicate elements, it will allow only unique elements. So first time it will store these three elements. Okay, and when it will check, okay, it is already existing the same element, then it will not add in the linked hash set. So output will be Delhi, Mumbai and Pune. Let's verify it. So in the output, we can see Delhi, Mumbai, and Pune. Okay. So this element Delhi is ignored. Okay. And if you see carefully, the insertion order is maintained. So we inserted Delhi first, then Mumbai second, then third Pune. So in the same order, output is coming first Delhi, then second Mumbai, then third Pune. So LinkedHashSet maintains the order of insertion. That means the order in which elements are getting inserted. Okay, so same order it will follow while retrieving the data or getting the data from the LinkedHashSet. Okay, so let's look at some of the common methods used in LinkedHashSet. So add we have used just now in the example. So add is used for adding an element. Remove is used for removing an element. Contains is used for checking whether an element exists in the LinkedHashSet or not. And size return the number of elements present in the LinkedHashSet. And is empty checks if LinkedHashSet is empty or not. It returns Boolean value, okay? And clear will remove all elements present in the LinkedHashSet. Okay. So these are the common methods which we'll use while using LinkedHashSet. Okay. So we have seen how the LinkedHashSet preserves the insertion order. So the order in which elements are getting inserted, it will give the output in the same order. Okay. So let's look at the difference between HashSet and LinkedHashSet. So we all know that. So before comparing any collections, first thing should come in mind is hierarchy. Where does it belong? HashSet, where does it belong? LinkedHashSet, where does it belong? So before comparing, the hierarchy should be coming in the mind. Okay. So these both are implementation classes of the which interface? Set interface, right? So and what set interface has the properties? So set interface has the properties only unique elements are allowed, no duplicate elements are allowed. Okay, so these are the implementation class of the set interface. Okay, as set we know, right? Since it implements set interface, it will also have the property. What property? Does not allow duplicates. Okay, and apart from duplicates, HashSet we know no ordering and no sorting. What does it mean? It means ordering means it will not remember the order of insertion, the elements order it will not remember, and sorting also it will not provide any sorting. Okay, and these two things if we talk about LinkedHashSet, so it maintains the order of the insertion, so it follows ordering but no sorting. Okay, ordering means it will maintain the order of insertion. Okay, let's start the difference. So HashSet does not maintain the order, no ordering. Okay, and whereas LinkedHashSet maintains the insertion order. So if you are giving 1, 2 and 3, the output will also be 1, 2 and 3. Okay, it will maintain the insertion order. It will maintain or remember the insertion order. HashSet is faster. Why faster? Because what is the internal data structure of HashSet is hash table. Internal data structure of HashSet is hash table. So it will use hashing algorithm. That's why it is faster. LinkedHashSet is slower. Okay, comparatively slower than HashSet. Okay, now see. it uses hash table as the internal data structure. Okay, hash table. And internal data structure for the linked hash set is hash table plus doubly linked list. We have seen in the diagram how it combines both hash table and linked list. So hash table, what it gives, faster in performance, okay? And linked list, what it gives, ordering, okay? It maintains insertion order. So it is using these two as the data structure. So these two properties it is getting, okay? So this point you should remember because this is a very important point. The internal data structure which HashSet and linked HashSet uses. So it uses less memory and it uses more memory. Okay. So HashSet is slightly faster. Why? Because it only uses a hash table. Okay. And linked HashSet additionally maintains linked list. Okay. Which requires more memory. Linked list, we know, right? Linked list means how it works. There will be node. It will have data and reference to another node. So it will consume more memory. Linked list will. That's why somewhat slower in performance and more memory consumption. Okay. But the important point is it maintains the insertion order. Okay, so these are the differences between HashSet and linked HashSet. So let's move. So time complexity. Okay, how much time it will take when we increase the number of elements. Okay, it can be linear. Okay, so for add, it is an operation. Okay, we are adding an element, we are removing an element. Contains means we are checking whether that element is present in the collection or not. So for these three, it is O of 1. Okay, time complexity. This is good. But for iteration, it is O of n. What does it mean, iteration? That means it will iterate through each element. Okay, it will iterate through each element. So it has to go to the each element. That's why O of n. If let's say if it has n elements, then the time complexity is O of n. Okay, so this was time complexity. What are the advantages of the linked HashSet? So linked HashSet is useful when you need unique elements. Okay, unique elements, and along with that, you want to maintain the insertion order. So if you need these two things, you can go for linked HashSet. So what are the advantages we get if you use linked HashSet? It will remove duplicates. It preserves insertion order, faster in performance, easy iteration, and it allows one null value. Okay, so these are the advantages. So apart from advantages, linked has said some of disadvantages as well. Okay, because see, more memory. Okay, why more memory we are saying than HashSet? So we know the internal DSA data structure being used in linked HashSet is hash table plus linked list. So these are the data structure being used by the, this is what this data structure used by linked HashSet. We are learning linked HashSet, right? So hash table will give faster in performance, no doubt. Why? Because it is using hashing algorithm. Okay, but linked list consumes more memory. Why? Because it will insert the nodes in the heap memory area. So there will be different nodes referring to another node like this. So this will consume more memory. Okay, it is giving faster in performance, but with more memory. And more memory, but it gives the feature of maintaining insertion order. Okay, so more memory consumption. Okay, more memory, slightly slower, no indexed based access. It does not support index based operations. Okay, and it is not synchronized. So these are the some of the advantages disadvantages of the linked hash set. Now, so when we'll go for linked hash set, what are those pointers we need to keep in mind before choosing linked hash set? So choose linked hash set whenever both uniqueness and insertion order are important. Okay, if order does not matter, then hash set is usually the better choice. Okay, but if you want insertion order and duplicate values are not allowed, then definitely linked hash set is the better choice. So when we should go for linked hash set, so use linked hash set when duplicate values are not allowed, insertion order must be preserved, and fast search is required. Okay, and ordered unique data is needed. Ordered and unique both. See, you want unique as well as ordering. If you need these things, then go for linked hash set. So we should know the features of linked hash set, then we can make the decision of using this collection linked hash set. Okay, so let's quickly summarize what we have learned so far. So we have learned linked hash set implements which interface? Set interface. Okay, it stores unique elements. So since linked hash set implements set interface, so it will be having the property of set interface, that is storing unique elements. It maintains insertion order. Okay, why insertion order it is maintaining? Because the internal data structure it is using is hash table and linked list. Since linked list maintain the insertion order, that's why linked hash set will get this feature. Okay, it allows only one null value. Okay, and the internal data structure being used is hash table and doubly linked list. Okay, and we have seen the time complexity is O of 1 performance average. Okay, so that's all for this video. I hope this tutorial helped you understand the concept of linked hash set in Java. Thanks for watching, and I will see you in the next video.